Welcome. In this lesson, we're going to continue what we talk about from the introduction of trig functions. We use the example to have gone over the definition, right? The important points about the introduction of trig functions. And first of all, we know that all the angles, right? What are the inputs for all the trig functions, sine through secant? They are angles measured from standard position. We know what the standard position is, which is the positive direction of x-axis, right? Positive direction of x-axis. Okay, we understand that. And the angles are measured from the standard position. All the angles for the input for sine, cosine, tangent, cotangent, cosecant, secant, all of these angles that use as input are measured from the standard position. If it's measured from counterclockwise, that's a positive angle. If it's clockwise, that's a negative angle. Secondly, reference angle. Reference angle is the positive acute angle between the terminal and the x-axis, okay? We haven't really used reference angle yet, but we will. And then we introduce definition, and we talk about the application of the definition to sine and cosine, while the terminal could be in different quadrant. The terminal could be in a different quadrant. And of course, our definitions is right here, okay? And today we're going to continue to talk about these for tangent and cotangent, right? So let's recap for sine. The definition of sine is from the angle measured from standard position as input, and the output is a ratio. The output is a ratio. So inputs are angles, output a ratio. What kind of ratio? Okay. The point is chosen from the terminal other than the origin. The point is arbitrarily chosen. It could be any points. Okay, then we work out the ratio over R. Okay, the ratio over R are the y coordinates of the point of selected point on the terminal other than the origin. And that y over R. So 4 over R, right? In this case, we did it, right? 4 over 5, right? Sorry. And in this case, of course, is 4 over 5, right? We did that. And in this case, is negative 4 over 5, right? So negative 4 over 5. Right, we can put the negative sign in front of it. And the last one, of course, in that example, we're still talking about the examples, okay? It's still negative 4 over 5. It's still negative 4 over 5. All right, so we figured that if the terminal in the first quadrant, sine is positive. If the terminal in the second quadrant, sine is positive. If the terminal in the third quadrant, fourth quadrant, sine, the output will be negative, okay? And for cosine, we did a similar thing, go by definition. The input are angles and the output are ratio, but what kind of ratio? X over R, so the axes are used, okay? The axes are used, so we have seen those examples. And today, we're going to continue this discussion. We're going to continue this discussion using the same example. Okay, the same example. Okay, I'm going to copy and paste this table, and it just in the same setting, we're going to work on tangent and cotangent. But in this case, right, you see we have the same stage set, but the rule has changed. The rule has changed. It's going to be tangent. It's going to be tangent. What is a tangent? Tangent is y over x. Y over x. Okay, so the rule has changed. The rule has changed. The rule has changed. okay? And R stay the same, but in this ratio, we don't really need R. You see, we don't need R, so we can remove this R, right? We don't need this R. And of course, we're going to determine the tangent. We're going to determine tangent. Okay, so I'm going to clean these up. I'm going to clean this up. Okay, so the ratio, right? So we have all these different angles and terminate different quadrant. So we're going to use y divided by x, y divided by x, which is also opposite over, you know, adjacent sides of the angle. But let's look at the measurement of these angles, right? So we're going to go just a little bit faster because we're following the definition, right? It could be this angle, that's A, right? And it could be the next angle. Oops. It could be the next angle, which is measured counterclockwise, right? And the other angle, it could be, it's all measured from standard position. You see, all of these are possible ways of measuring our angles, right? It could also be that counterclockwise. All of these are possible, isn't it? So these are the angles. So this angle A, and this is possible angle A, and these are, this angle is A, and this angle is A. What matters to determine the ratio is the terminal. The terminal could terminate in the first quadrant, second quadrant, third quadrant, or fourth quadrant. In these examples, okay, in these examples, let's see how we're going to apply the definition, okay, on this stage set, So tangent of A is y over x, right? Y is a vertical, x is a horizontal, right? And we know that, and so this is going to be 4 over 3. And in the second quadrant, right, for this particular angle, tangent A is going to be 4 over negative 3. 4 over negative 3. 4 over negative 3 is negative 4 over 3. Okay, you don't have to convert it to, you know, convert this improper fraction. We can just take this, that's fine. So, and tangent angle, if the terminal end up in the third quadrant, so the ratio is going to be negative 4 over negative 3. Negative 4 over negative 3. And that's going to be positive 4 over 3. Okay, and the next one, okay, the last one. The terminal ended up in the fourth quadrant, right? So this time it's going to be negative 4 over 3, which is still going to be negative 4 over 3. Negative 4 over 3. Okay, now, right, if we observe the sign, you can see the sign is determined by x and y. When both x and y are positive in the first quadrant, tangent is positive, right? Or you can say tangent of this angle is positive in the first quadrant. In the second quadrant, right, x and y, these are opposite in sign. So when we're doing the quotient, a positive divided by negative, it's going to be negative. Principle number 6, right? In the third quadrant, negative divided by negative is going to be positive. In the fourth quadrant, tangent is going to be what? Is negative divided by positive, it's going to be negative. Okay? So that's tangent. How about cotangent? Cotangent, okay, in similar situation, right? So maybe we can insert another rule because cotangent is x over y. By definition, cotangent is x over y, right? So it's a reciprocal of tangent. Right? So let's make another table. Let's just make another table. Okay, we're gonna summarize all of these just after we're done with all of them. Okay, so now we have all of these functions. Oopsie, sorry, tangent, right? So let's work on cotangent. Cotangent, the rule is different. It's different. But how different? It's just x over y. X over y, right? So that's a cotangent rule. It still take the same kind of input, which is measured from standard position, right? The only thing is the rules are different. The rules are different, right? You can see cotangent is a rule that takes angle as input, angle measured from standard position, the output are ratios. And this ratio, since it's a cotangent, right, is 3 over 4. 3 over 4, right? So cotangent, which is a reciprocal, right? Which is a reciprocal of it. So it's going to be negative 3 over 4, right? It's x over y, negative 3 over 4. On this other one, it's negative 3 over negative 4. So this is going to be positive 3 over 4. And in this one, it's going to be negative 3 over 4. Sign-wise, same sign, same sign, same sign. Now, right, so you can see we can get so much information out of that definition. We have 2 more functions to go. 2 more functions to go. So what are those? Cosecant and secant. Okay, for cosecant, okay, let's take a look at the definition of cosecant, right? Cosecant is defined as r over y. Sine is defined as y over r, right? So it seems that cosecant and the sine has some relationship. They're reciprocal to each other, isn't it? Okay, so I'm going to bring back my sine. I'm going to bring back my sine, which is right here, right? Which is my sine. And next to the sine I have just studied, I'm going to change it to the new rule, cosecant, right? It still takes the same kind of input, which measure from standard position, right? The angle measurement, but r over y. You see that? Okay, so the rule has changed. The rule has changed. The rule has changed. Okay, we still use the same example, and r, the same way calculation. And now it's a cosecant A. It's a reciprocal, right? Y over r, now it's r over y. So 5 over 4. And sine didn't change. The sine is still positive, right? Still positive. And cosecant A now is 5 over 4. 5 over 4, reciprocal of it. Okay, so cosecant A is negative 5 over 4, right? And cosecant A is negative 5 over 4. You guys see that? Okay, so you can see from definition, we can also derive that, oh, look at that, sine and cosecant, if one is positive, the other one is positive, and cosecant is positive, first quadrant, second quadrant, third quadrant, fourth quadrant are negative for cosecant. Okay, now for the same reason, let's observe cosine and the secant. Okay, cosine and secant. So how is the cosine and secant defined? So cosine and secant, how are they defined? Okay, maybe I should, make some change of order, right? Make some change of order about these functions, right? For our convenience, right? So I'm going to bring cosecant next to sine, right? So I'm going to remove this piece, right? And I'm going to move secant right next to cosine, because they're reciprocal to each other, right? They're reciprocal to each other. And the tangent and cotangent are also, reciprocal to each other, So cosine angle and secant angle, if we study them and we realize, hey, I can get a lot of interesting information about cosine. So I'm going to take this table, right? And and make another table for secant, right? For secant, the rule has changed to be what? It's just R over X. R over X. Okay, so the rule has changed. The rule has changed. Okay, if a terminal are in different quadrant 1, quadrant 2, quadrant 3, quadrant 4, doesn't matter. We know how to handle it. And the secant A is going to be 5 over 3 because they're just reciprocal, right? And secant A terminates in the second quadrant, it would just be what? Negative 5 over 3. That's the reciprocal, right? The third quadrant, secant A is going to be negative 5 over 3 as well. And the sign are stay the same, okay? So secant, that's the sign stay the same. Sign stay the same, right? And we can also use positive sign, negative sign, right? And that's a negative sign, and that's a positive. Okay, so let's finish that. Okay, so that's going to be 5 over 3. 5 over 3. Positive, right? And for cosine, we could have done the same thing, and these just, we can introduce another row, right? So that's going to be positive, negative, negative, positive. Oh, wait, sorry, this is cosecant, right? So this is a positive, negative, negative. Okay, my bad. I was looking at the wrong thing. Okay, cosine, which is right next to secant. Secant, where's my cosine? Oh, there's my cosine, my bad. Okay, so this is a positive, negative, right? I was looking at the wrong table. Negative, positive. Okay, so we have covered all 6 functions in terms of definition. And from these definition, right? Let's review the definition. Standard position. Okay, standard position, angle measurement, reference angle, which you haven't used, not yet. And we rearrange these, trig functions, and we found that they are reciprocal to each other. We're going to come back to take care of that, okay? We're going to come back to take care of that. And we cover tangent, cotangent, right? Cosecant, secant. And here, as a summary, we can tell, right? We can tell, the sign of different functions in different, different quadrant because of the terminal, right? Where the terminal is. And here I prepare a picture here, right? From the definition, I wish to give you a little more compact summary. about the sign in different quadrant. About the sign in different quadrant. Okay, when terminal terminates in different quadrant. When terminal terminates in different quadrant, right? The standard position, we measure angles. If angles ended up in different quadrant, right? Sign is positive, positive, negative, negative, because sign is what? Sign is y over r, y over r, okay? So I'm gonna put this function definition right here. For the sign of, for the ratio of sign, we know the angles are, are measured in a certain way. We know how to measure them. For sign, to see the sign for sign in different quadrant, all you have to do is just looking at the y. This is the y, right? If the y's are negative, then sign will be negative. So sign is positive, positive, negative, negative. How about cosecant? The same thing. Y over R, R over Y, the same thing. Cosine A, cosine and secant, one is X over R and the other one is R over X. So X determine the sign. X determine the sign. So what are axes? These are the axes, right? So that's why cosine is a positive, negative, negative, positive. Tangent and cotangent, tangent and cotangent. Tangent and cotangent are reciprocal to each other, right? You basically do y over x or x over y. It doesn't matter whether x over y, y over x is going to give you the same sign. So in this case, positive divided by positive is positive. Positive divided by negative is negative. Negative divided by negative is going to be positive. Positive divided by negative is going to be negative. So that sign can be easily determined by the definition. By the definition. Okay, so that's the, just from definition. Okay, let's summarize. This definition is very, very powerful. Very, very powerful. Okay, so let's recall that definition. Let's recall that definition and summarize, right? The definition is calling us to pick up a point on the terminal side of the angle other than the origin, right? And everything will be defined. Everything will be defined. So this piece is the centerpiece of trigonometry, okay? Includes standard position, angle measurement, reference angle, angle A, okay, as input, and the angles are measured in this way, okay? Angles are measured from standard position, counterclockwise, clockwise. The output are ratios of different sorts, okay? The outputs are ratios. Inputs are angles, output are ratios. Okay, so that's very, very important to understand. So now we have 6 functions. We have 6 functions, right? And we're going to study these 6 functions from definition, Earlier on, we have a discussion, right? Because we choose this point arbitrarily on the terminal, which is not the origin. Will they produce the same ratio? That's the question. Will they produce the same ratio? Okay. And the answer is yes, but let's look at it. Why? Let's see why. Okay. So some of you who have some prior knowledge about trigonometry, you probably know about the unit circle, right? Then the question is, why unit circle? Why unit circle, right? We know unit circle has a radius equals to 1. Why don't we use a circle radius 2, radius 10, radius 5 in this example, right? In this example, we did the radius is 5. Okay. So with that question in mind, I'm going to start another, I'm going to do another lesson. Okay. So this way we will have a focused topics. You can have a focused topics. So I'm going to stop here, and thank you for watching. And we're going to see you at the next lesson. Thank you for watching.